3I/Atlas, the interstellar messenger. Something extraordinary is happening in our solar system right now. Something that has never happened before in the history of human observation. A visitor from beyond the stars, a cosmic traveler that has journeyed for billions of years through the cold darkness of interstellar space, is now passing through our cosmic neighborhood. And for the first time in human history, we have the technology to watch it, study it, and perhaps unlock some of the deepest mysteries of what lies beyond our solar system. This is the story of 3I/Atlas, the third confirmed interstellar object ever detected by humanity. And unlike anything we have seen before, this object is raising questions that scientists are struggling to answer. Part 1: The Discovery. In the vast darkness of space, millions of objects orbit our sun: asteroids, comets, dwarf planets. We know them well. We have catalogued them, tracked them, studied them for centuries. But sometimes, something appears that does not belong here. Something that carries the fingerprints of another star, another world, another cosmic origin. 3I/Atlas was first detected by astronomers using advanced survey telescopes designed to spot faint, fast-moving objects. When they calculated its trajectory, something remarkable became clear. This object was not following the typical orbital path of a comet or asteroid born in our solar system. Its hyperbolic orbit, a path that curves around our sun and then continues outward into infinity, revealed its true nature. 3I/Atlas came from somewhere else. Think about that for a moment. Every rock, every chunk of ice, every piece of dust that normally exists in our solar system was born here, from the same primordial cloud of gas and dust that formed our sun 4.5 billion years ago. But 3I/Atlas? It formed around a completely different star, in a completely different planetary system, possibly billions of years before our own sun even existed. This is only the third interstellar object ever confirmed. The first was Oumuamua in 2017, that strange cigar-shaped rock that sped through our system so quickly we barely had time to observe it before it vanished into the darkness. The second was Comet Borisov in 2019, which gave us our first glimpse of an interstellar comet, complete with a coma and tail. And now, 3I/Atlas. Each one unique. Each one carrying secrets from the depths of the galaxy. Part 2: What the images reveal. The latest images of 3I/Atlas, captured by astrophotographer Dan Bartlett, have sent shockwaves through the astronomical community. Not because of what they show, but because of what they do not show. Look at the first image. At first glance, it appears calm, quiet, almost peaceful. A small, bright nucleus surrounded by a soft, glowing coma. The greenish tint is immediately striking, a telltale sign of carbon-based molecules, specifically diatomic carbon, fluorescing as sunlight hits them for the first time. This green glow tells us that frozen gases, locked inside this object for billions of years, are finally waking up as it approaches the warmth of our star. Behind the nucleus, a smooth, narrow tail stretches outward. Not chaotic. Not fragmented. Not tumbling wildly through space like many comets do when they first encounter the sun. Instead, this tail is clean, controlled, almost elegant in its appearance. It is as if this ancient traveler knows exactly how to respond to the solar wind and radiation pressure it has never experienced before. Now look at the second image. Here we see 3I/Atlas in even greater detail. The coma, that fuzzy envelope of gas and dust surrounding the nucleus, is remarkably symmetric. This symmetry tells us something profound about the structure and composition of the object. An unstable, rotating, or fragmented nucleus would produce an asymmetric, chaotic coma. But 3I/Atlas shows none of these signs. What makes scientists truly pause is what is not happening. This object is not falling apart. It is not spinning wildly out of control. It is not exploding with debris like many solar system comets do when they make their first close approach to the sun. Instead, 3I/Atlas appears stable, ancient, preserved, almost untouched by time. This level of stability is extraordinary. It suggests that 3I/Atlas spent billions of years drifting through the cold, empty void of interstellar space, where temperatures hover just a few degrees above absolute zero. In that frozen darkness, it remained pristine, preserved in a state that existed before the first humans walked on Earth, before the dinosaurs ruled our planet, possibly even before life itself emerged on our world. Part 3: What is it made of? Understanding what 3I Atlas is made of is one of the most exciting challenges facing astronomers today. Every molecule, every element, every isotope we can detect is a direct sample of material from another star system. Spectroscopic analysis, the science of splitting light into its component wavelengths, is already revealing clues. The green color we see in the images comes from carbon dioxide and cyanide compounds fluorescing in sunlight.